Okay, we have the leading coefficient test. No, that's Fred Astaire's and Ginger Rogers. They may be dancing and he may be leading, but that's not what the leading coefficient test is. All right? Leading coefficient test, first off, let's think about what is a coefficient. It is the number in front of the, like x to the n or x squared. Those are all coefficients. These a values are coefficients. But the leading coefficient would be the first one, or the one with the highest degree right there, provided that the is not equal to 0, but that kind of goes without saying, because if it's a 0 there, it wouldn't exist. So, and they essentially rise or fall. And what that means is this. When the leading coefficient, when n is odd, n of the exponent, that is the degree. When the degree is odd, like in this problem right here, notice you have it 1, a 3, a 5. Doesn't matter what these are. They could be 2, 4. As long as that first one, the biggest one, is a 5, it makes the whole thing an odd function, because that's going to outweigh the others as you approach infinity. So what happens is this. It'll look something like this here. Actually, I think that is that actual graph right there. Would look something like this here. It is a polynomial. It is continuous. And what I want to notice about this odd is this. Notice the right behavior, if this is positive, is going to go to infinity and beyond. And think about it. If you have negative values here, they're going to be very large, and it's going to go to negative infinity. So an odd function will rise on one side and fall on the other. And here's how you know which it does. If the leading coefficient is positive, like it is right here, that would be a 1 in front of that. And it's positive, that means it's going to go to the positive infinity at the end on the right. And so that means the graph would be falling on the left. Help, I've fallen and I can't get up. Not quite like that, but. Now, let's suppose if the leading coefficient is a negative, like this one here, basically it's the same graph, we just what? Flipped it. And notice, because as you're approaching, as you have a number here that is positive to the 5th power, it's going to be very big, but that negative in front is going to make it, instead of going up, going to make it go down. So what the leading coefficient does is this. It determines what we call the right-hand behavior. The right-hand behavior is the last thing it does from the point where it crosses the x-axis. And from there it's going what? Down. Here it's going up. This one's down. Notice the negative one, right, going down last. And so then a negative times a negative times a negative times a negative times a negative is all negative. But then when you multiply it by that other negative, makes it go positive. So it's flipped. So if the degree is odd, you're going to have one going up and one going down. Okay, well, what happens if one is even? Well, think about it. If we have an even thing, it doesn't matter whether that's positive or whether that's negative. When you take a negative times a negative, negative times negative, you're going to get a positive. So my things are going to go, the behaviors are going to both go up, or they're both going to go down. And they're going to go up when this coefficient is positive. Notice, that would be a positive one right there. And this is the graph of that particular equation right there. Okay? And you'll notice that that's a 4. Notice they both go up, just like a quadratic. Quadratic was a parabola where they both went up or they both went down, depending on whether the first value is either what, positive or negative. Well, this one's positive, so the end behaviors, the very last thing they do, are going up, both of them. Well, what happens if it's a negative? Well, instead of going up, they're both going to go down. And this is this particular graph right here. Notice, because even if you take a negative times negative, 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 you get a positive, but then the other negative is going to make them all go down. So here's the thing. Even functions, both graphs are going to do the same. Odd functions are going to do something, each going to do something different. All right? So let's take a look at a little practice at this here. So what it means is this. This first one right here, notice, it is a degree of 3. That's the question you ask yourself. What is the degree? It's 3, which means it's odd. So the next thing I know is I know they're going to go opposite directions. So they're going to be different. Okay? The next thing I look at, the leading coefficient. Is it positive or negative? It's negative. So I know the one on the right has to go down. And because they're different, the one on the left has to go up or rises. The right falls and the left rises. Now you're going to have some homework exactly like these problems right here. And this is what you're going to do. I want to see left rises, right falls. So on this one, let's look at it. What is the degree? The degree is 4. 4 is even, so therefore they're both going to go the same. So the leading coefficient is what? Positive. So that means the right behavior will go up, rise, and because it's an even number, they're both going to do the same. Someone's also going to rise. Now look at C. What is the degree here? The highest degree is 5. It should be a 5. I don't know where I got that 1, but it's still odd. It's 5. It's odd, and it will be different. So therefore, that means that they're going to go what? Opposite directions. And the first one is positive. So the right one's going to rise, and the left one will fall. That's what's going to happen on it.